My name is Yosef Dinerstein. I'm a developer at Microsoft. I work in online services division. There's a division behind Bing.com and some other services. And I worked in a group that developed experimental applications, experimental web and cellular applications. And we faced the challenge of developing very fast. We need some agile ways to develop, and we got permission to use any technologies we want. So we started to work on Azure as a cloud, and very soon we discovered that one of our major requirements is the ability to develop on cloud like it is on local machine. We need it very fast. We make change, few seconds. We want this to be deployed. We want to work on with our applications on the cloud directly. And out of this need was born Anode. So Anode is a PaaS, platform as a service, that allows developing and hosting of web applications. It is not a huge project. It's a fairly small project developed over Node.js and hosted in Azure. We started to work on it about a year and a half, and we spent roughly 2 developer years invested in this project. All the time that we worked on Anode, in parallel we developed our web applications, and this way application evolved and the platform evolved to the point that it is now on. So why did we build it? As I said, we wanted to develop on the cloud, and we choose Node.js technology for several reasons. JavaScript, in fact, I think it's a great language if it's used correctly. And while we have all the client code, the web application written in JavaScript, it became very convenient to write server-side on JavaScript. Node.js is an asynchronous platform. It allows scaling up. Together with Azure, we can execute multiple nodes on multiple servers and to scale out our services. It's easily to deployable. Scripts are very easy to deploy. And one important thing that Node.js has a big community of developers behind it, so almost everything is in place. In fact, in our Anode system, just 10% of code are written by ourselves. We reused available open source libraries for Node.js. For example, the proxy stuff we took from a similar platform developed by Nodejitsu. But this platform, for example, doesn't work on Azure, ours does. At the time we started, Azure didn't have its own native support for Node.js. Now it does. So our solution still uses Node.js. We just launched Node.js processes. But today you can use Azure with Node.js in it. You can just start web service out of Azure portal, and it will be Node.js driven web service. So you can see Anode, it is not official Microsoft answer to working on Azure or for working with Node.js. It is an open source project that was just originated inside Microsoft. You can see it as a complementary solution to what Azure already offers in Node.js. The features of Anode are around several areas, and I will go into details on each of these areas shortly. It's about management UI, deployment system, logging infrastructure, testing infrastructure, security, wrapping, and a few helper services. So it's not doesn't cover all the aspects of DevOps, but some of them. Our management UI is a web UI. One of the requirements was no tools need to be installed for developer. It's you can take any laptop, PC, Mac, and you can work. So all the management and all the work with Anode is through web interface. We introduced command line interface paradigm as a friendly paradigm for developers. And it is integrated with the web. I will show in demonstration. And this UI framework is extendable. It's built as a bunch of commands, and there is plugin to the framework behind each command with its documentation and logic. And it can be extended for more and more commands, system commands, or even application commands. So somebody that develops application for Anode can create some management command for it and integrate it in existing management framework. The deployment, this is all about deployment. It should be fast. We want to develop directly on cloud, and it involves tens interactions, tens turnarounds through the day for each developer. I make my change, I deploy it, I test it, I debug it, and I deploy fix, and so forth. So it should work very fast. It should work seconds on the real cloud. Another major feature that we have is multi-tenancy. We want to run multiple applications side by side, and some of them system applications of Anode itself, some of them applications that are developed. And another point, we want to run multiple versions of the same applications side by side, so that you can develop feature on the same platform, on the same hardware, on the same Azure farm that hosts your production. It's both for saving the money and also you really can develop your stuff on a real configuration. We have integration with source control. Also, the requirement was you write your code, you put it in source control, you commit it, and it deployed automatically on the cloud. So the source control that we used here is an open source, widely used Git, and we specifically have good interaction with, good interface with GitHub website and Bitbucket website. And this deployment system is quite flexible. Administrator of Anode farm can configure which repositories to deploy. Repository is just a GitHub repository. It can have multiple applications in it, one application in it. It can have multiple branches, and administrator can decide which branches to deploy and how. The logging is also a very important factor for development on cloud. It is the information that comes from running application, and we need it live, we need it real time. So it's instant logging. Log is written by application, and it can be immediately seen by developer. The logs are made queryable, so you can see logs that are relevant only for my application in certain amount or in certain time from certain server out of in the farm of servers. And of course, logs are also persistent, so I can get and see historical logs or to some horizon that can be configured. We keep logs for months. So I will start with a short demo that will show our development, our demonstration farm. It's that we will run demonstration on it. We will take some view of management UI, and I will introduce a sample application that we can use through the demo. We will make change in this application later, and you are encouraged to start using this application. So what I see here is a Azure portal that shows our demonstration farm. It is a farm of 3 servers. it can be scaled out to 200 servers, depends on if I need to real scale out, but I just for demonstration purposes, I created here 3 servers. Each of them runs Azure Anode.js role, which implements Anode. And when you create this farm, it has a name, so it can be accessed as anodedemo.cloudapp.net. Cloudapp.net is Azure domain, but we mapped our own domain to the same farm. It's called demo.msproto.net, and I can access now Anode management UI through browser. So I will use different browser here for convenience. And I'm going to the management UI. That happens when you do live demo. Sorry about that. Looks that I don't have network. Just trying to make network work. Okay. Demo. Okay, I get it. So just a network problem here. Okay, so this is the UI. This looks like it's a website. Has commands that are easily discoverable. For example, help. I can get a list of commands. I can see, for example, I have a log command here. I can see the help about log, how it can be used. I can run log and see the latest log coming from the farm. So here I can see the logs written by several applications. For example, here some application called chronos.sys logged something from instance 2, which means server number 2 in my farm at some time. By the way, what we see here is GMT time, so it was just a few seconds ago. Okay, so about the demo application, so you can connect to this application and start using it. It's Hyde Park demo. It just chat room that we all connected to, and okay, somebody. The catch here is that people are connected to different servers at the same time, and the application routes messages between these servers. So naturally, you can see that such application would be challenging to develop in some emulated environment. You need a real environment with multiple servers, and this just demonstrates the need to develop directly on the cloud. So this application will continue to run through the demonstration, and we will introduce change in this application. You can continue to use it and to chat with each other, and you can continue to use it even after the presentation is over. Okay. Just a glimpse on high-level design of Anode, users and developers, they access Anode Farm through Azure Load Balancer, which routes requests to one of the servers, whereas Azure calls them instances, one of the instances. Each instance executes the same role, it runs the same code. The major part here is reverse proxy. It is a Node.js process. All Anode is 99% it's Node.js code. And reverse proxy is responsible for security wrapping. It gets requests. It understands to which application the request is destined. It is responsible for lifetime of application. If application doesn't run, it starts it. If application idle for a long time, it will terminate this application. It will route requests to the application. It will pump data to the application. Supports WebSockets, everything. The applications are applications like HyperPark that we just seen here, and it can be system application, which constitutes Anode. Anode is built as a bunch of Node.js application, and each application built up multiple modules. Most of those modules are modules we took from the community, and we, for example, I mentioned proxy module taken from Nodejitsu, and we developed some of our own modules that are available to reuse by others. For example, we developed module for communication with Git. Some of the system applications, more important applications like deploy, is responsible for deployment. It communicates with GitHub, it gets notification from GitHub, it can take code from GitHub, particular repositories, particular branches, and to place it on file system, restart the application so the change get deployed. Console application is the backend of the management UI that we just seen. Configuration manager is another application that monitors farm configuration. For example, if farm will be scaled out or scaled down, it will notify. Application like HyperPark needs this to see how many servers there are. Kronos is scheduler. So now the how deployment works, it's just as I said, developer writes code, submits it into source control. Once it in source control, it just gets deployed on farm in parallel on all servers or in all instances. What happens in fact is that we get notification from GitHub, or for example from Bitbucket, and we pull code and place it on the file system. The placement of the file system also defines namespace of the application. So it depends how application is placed. We create some sort of name for it. And I will show this in this demonstration. So what we will see now is the full development cycle. I will try to introduce a new feature into this HyperPark application. For that purpose, I will deploy the new version of this application side by side with application that is kind of production environment right now. It will not affect the production. You can continue to use it. I will show also deployment configuration, how it works. And we will integrate eventually this change into the production environment. So I will start here with it's better that Windows will work. Yes. Okay. So we have this HyperPark application here on GitHub, and I will create new branch. I will name this branch this way, just the name Yosef D6 minus D. So why did I name it this way is because of my deployment configuration. I will show you the deployment. Oops, close it. Just a moment, it's here. The deployment configuration is just JSON file, and it says how to deploy different repositories. So in this example, I can see that I deploy a few repositories. For example, I deploy this playground repository, PG, and I choose to deploy it in PG directory. But I also deploy something called PG STG, where STG is a branch of this repository. I deploy it in parallel in different folder. Specifically, our Hyde Park, its master branch or its default branch is deployed as Hyde Park. So the name goes hydepark.demo.msproto.net. But I also choose here as administrator to deploy multiple branches all in once, and can do it with regular expression. So I choose here to deploy all the branches that end with -d into file system under directory with the name of the branch without the suffix and subdirectory Hyde Park. So I created some deployment rule that is quite open and lets developers of this project to create deployable branches without interacting with me, just by matter of naming them with -d suffix. But it's just a choice of configuration, not something hard-coded in Anode itself. I can create any deployment policy I want. So this is why I just named it Yosef D6. This branch doesn't exist yet on GitHub, but once it will be automatically deployed. So I will go to this branch here, and I will introduce the change into the application. So this is the code of the Hyde Park application, the server-side code. Notice it's a small application. It's under 300 lines of code on server side, another 200 lines of code on client side. And I will create new feature. For example, I will create some statistics feature. I will count number of messages passing through this application, and on demand I will let user to see how many messages passed through the application. So let's introduce message counter somewhere. And count all messages that come from clients and messages that come from other servers. So here we have handler for messages. When messages arrive from client and we do something with them. So I will put here, increment the count of messages, and another place that I have that messages are comes when they come from peer servers, from different servers. And it should be here. So notice that this code is executed only when we have multiple servers. So if I would run this application in some emulated environment, I will not exercise this change at all. So this just demonstrates why I need working directly on cloud. And I will just reply on demand with count of messages if somebody sends message that includes sharp stats in its text. So if it matches regular expression, stats, we will try to, let's put some logging here. maybe it will help us to debug. And we will reply with the count of messages to the caller. The message, it is a JSON object that has a text in it. And it has also the nick of the person who sent the message. So let's call it robot. And we have also the peer server. So I hope this is the change, and I hope it will work. What I need to do is just to put it into the source control and submit it into GitHub. Okay. So this is supposed to create a new branch on GitHub. Just git work. Yeah, it created new branch. And I hope it's there. See? Yeah, we see this new branch here. And I can use deploy command of management interface to see the status of deployment. And what I can see indeed that this branch, Yosef D6, was deployed just now, a few seconds ago. The time we can see here is GMT time, so it is indeed a few seconds ago. And what I wanted to emphasize here is that interface is built, it is a command line interface, but it leverages the richness of web, because I can dig down into information here and see history of deployment of this particular instance, and per each repository to see history of deployment on this repository. So it takes strength of command line interface together with interactive UI. So it shows some compact view of information, but it includes all the information there. So the application was deployed. I can access this information and start to test it. It should be named according to my deployment as Yosef D5, Yosef D6, sorry, demo.ms photo. Just a few minutes. Yeah. I'm at the end almost. Yeah. So ignore this warning. We have DOM certificate, wildcard certificate that doesn't cover such long names. So these applications are in parallel to the production one. I can check it works. I can check what happens when I write stats. It's supposed to answer, but it didn't. I will check with logs. Arc D6. Okay. Okay, what we see here is we had exception there because the name of the method was not correct. I will see where it is. So I will just, it's 1 minute. I will just fix the code. Here is the bug. And the fix goes immediately into the source control. that it gets immediately deployed on the cloud, so I can see the results immediately here. It was just deployed, and test it again. And the feature just works. Okay, so I will complete the development process through code review and all the what it is necessary to integrate it. Just a few seconds from the end. I will create pull request with my change, new feature. Submit this pull request to the working group. People can review it, see the change, and eventually we will integrate this change into the production by merging the change into master branch. And once we get it here, we can see that it gets deployed. Not yet. So it will be deployed in a few moments, and once it's deployed, it will affect the running application. Okay, it is deployed, and if you use the original Hyde Park application, you can notice that this change already works in your application. You will probably require to enter your nickname again, but it should work on production environment right now. So that's the demo. And to summarize, as I said, Anode is a open source platform for working on Azure. It was developed together with application, one of them Onyx.ms. You can later see what it is. It's a cool Android phones application. Anode will be available as open through GitHub in 2-3 weeks. We just finished our legal review with it to make it public. And you can contact me if you have any questions or you want to use Anode or whatever. For any questions, yosefd@microsoft.com, Twitter. Thank you very much. If you have any questions.